Hello everyone, welcome to my channel. My name is Amit. In this video today, let's learn how we can DevOpsify an application. That means we want to use different DevOps tools to streamline our application's workflow. Let's start with a simple web application. This will be a one web page or one page website index.html. We'll Dockerize it, means we'll run this inside a container using a tool called as a Docker. To make this application highly available, we'll be using a Kubernetes, which is container orchestration tool, which is very popular in the DevOps world. We'll run the Helm chart to deploy the application into the Kubernetes cluster, which will make our life a little bit simpler. For continuously integrating and continuously deploying this application, we'll be using GitHub Actions, which is going to be representing the CI, and we'll use Argo CD, which is going to represent the CD part of the pipeline. Let's begin. I have created a small application here. It's a one-page website, index.html, which has only one h1, which is the header, and h3, just to say that it's a demo application. And this is how it looks like. Very simple application. Okay, let's start with the first tool, Docker. To run this application inside the container, we have to create the Docker image. To create the Docker image, let's create a file named Docker file. Make sure that you are having the D capital there. Most probably D small will also work, but it's recommended to have Docker file with D capital. Anyways, let's start with HTTPD. That's our base image. From this image, we'll copy our own HTML file into /usr/local/apache2/htdocs. This is the web root for Apache. Though it is not needed, but it's always better to expose the port 80. Now when I say it is not needed, because HTTPD already has done it. Anyways, we'll do it. Now the Docker file is ready, let's build our image and see how we can push it to our Docker Hub account. So to build an image, we'll say Docker image build -t, T for tag. I'll use my website and then dot for context. Wonderful, it's creating an image. It will take a second, and once it is done, we can verify that by saying Docker image ls, and I can see my website image just before 4 seconds is now ready. Now what to do with this image? If I want to deploy this application inside Kubernetes cluster, this image must be publicly available. To make it publicly available, we'll have to create a Docker Hub account. So let's go to the Docker Hub here and let's create our account. I already have created mine, so I'm going to sign in with my account. Okay, let's log in. So once you log in, you will see all the images, those you already have created before. I mean, since if you are creating the application for the first time, you might not see any, which is all right. Now I want to use this account and push my image into this registry here. So going back here, I want to push this image, but as per Docker Hub rule, if you want to push the image to the Docker Hub, you have to first rename your image, which starts with your account. Now if I look at my account name here, it is Python CPP, so I'm going to tag this image with my name by saying Docker image tag. My website is the name of that image that we already have created, and I will rename it, or I will tag it as Python CPP/my website. Python CPP is my account, so if you are creating yours, please replace it with your account. So let's tag it. If I tag it, you can see the same image. If you look at the image ID, it's the same image which is listed twice. Once the original name, my website, another one is Python CPP/my website. Now let's push this image to our Docker Hub account. So Docker image push Python CPP/my website. That's it. So it will take a minute, and this will push the image to our Docker Hub account. Let's wait for it. Okay, almost done. Okay, done. So now if I go back here, give a quick refresh, I should see that image is listed here, which is exactly what I can see. Maybe uploaded just a minute before. Okay, if I click on that, I can see there is a latest version available. This is the tag, you can call it as, and this is available or rather this is uploaded a few seconds ago. Wonderful. So from our list, we are done with that. So let me mark it as done. We are done with this as well. So mark it as done. Now let's focus on the Kubernetes. Now since Kubernetes cluster can be created anywhere, which is always recommended to create on public platform, like something like an AWS or Azure or something like a GCP, which will make the application global. But at this time, because if you're going any of these platforms, you will have to pay, and I don't want anyone to pay just to run this application. So I will create a Kubernetes cluster on my local machine by using a Minikube. So let's head towards the Minikube documentation. Those who haven't installed it before, you can simply come back here, choose your operating system that you are using, choose your architecture, if it is x64 or if it is ARM, choose a stable and simply run that command. I already have installed this, so I'm going to start using this direct Minikube start. This command will install it, and this command will start creating your cluster. So let me head towards my command prompt and use the command, it's Minikube start. Now because I'm running on Mac and there is no other driver than QEMU is working on that, that's the reason I'm going to specify driver QEMU and the network as a socket VMnet, so I can directly access the application running inside that cluster. Let's start this cluster. It will take a minute or two. So what essentially it does here is it's going to create a virtual node which will act as a master as well as a worker, where you can run your containers in terms of pods. So essentially once it is done, it is ready for creating or running our application inside multiple containers. So to get this working inside the Kubernetes, let's come back to our application and let's create a new directory here. Maybe I can call it as K8s. Most probably K8s means it's like Kubernetes, but again it's up to you. Name really does not matter. Inside K8s, let's create another one which generally called as manifests. Manifest, think about it as a configurations. So inside this manifests, let's create a new file for deploying our application, which is generally called as deployment. So deployment.yaml. Now if you are using Visual Studio Code, there are many extensions which will make your life a little bit easier. So if you go to the extensions and search for something like Kubernetes, yes, here it is. You can install this one, which is officially given by Microsoft, and this will help you to create all of your YAML files easily, So going back here, and I can search for deployment, and this will create a deployment file for me. Again, when you are in the DevOps, no one would really want you to remember every single part of it. So it's better you can always go back to kubernetes.io, go to the documentation and search for the YAML file which you are looking for. For example, if I'm looking for something like deployment, so Kubernetes documentation is very good. So you can go to the documentation, and every single type of entity they have added documentation along with its required YAML file. So simply put, you come back here, you copy and paste it. But just to save my time, I'm using this extension called as Microsoft Kubernetes. Now I have got the deployment YAML ready, which starts with API version, apps v1, so on and so forth. Maybe I can change that to my website, something sort of that. We'll use a label as app my website. Make sure that the application label, or you can say the label that you are assigning here, is the same one that you are going to assign to your pods, like this. Otherwise it won't be able to select all those pods which are managed by this particular deployment. The container here, maybe name doesn't matter, I'll use that my website here. This is important. Here I will use that image that we just have pushed. So Python cpp/my website. That's it. If you want, you can keep it. This is the resource requirement. Important thing here is the container port. The container port here is port number 80. Wonderful. My deployment file is ready. Now to make this deployment available to the external world, we have to use another entity, another object called as a service. So going back to the manifest, I'm going to go back and create another one, service.yaml. Again, you can head towards your documentation, search for a service like that, and again copy and paste the service's default YAML file or default YAML definition, which is as simple as that. You can do it like this, maybe copy and paste, or if you're using the extension, then you can just say service and this will create it for you. Okay, going back here, I'm going to change that name to my website. Name really does not matter. What matters here is this selector. Now since my deployment.yaml, I mentioned app website is my label, I'm going to use the same label here, app my website. Port, I'll use that port number 80, and I'll make that target port as 80 as well. Same. I think we are done with that. We are having a deployment and we are having a service YAML definition. This service, the one which is going to create, is called as a cluster IP. Now when I say cluster IP, it will be visible within the cluster, not outside the cluster. So if I want my application to be available outside the cluster, which is generally the requirement here is, I'll have to go back to the spec and say the type of it is something called as a node port. So in case of Kubernetes, you are having different types of services. Out of that, cluster IP is the default, which will make that service only available to the cluster. But if you want that service to be available external to the cluster or outside to the cluster, we have to check that type, whether it is node port or not, which we already have set it now. Wonderful. Now that deployment and service files are ready, let's see whether the Kubernetes cluster or the Minikube cluster is available. And since it says that the kubectl cluster is available now, we can start using it. Now once you install that Kubernetes cluster, in the documentation you may find one kubectl alias, which you need to put it inside your bash file or maybe ZSH file, depending again on the shell that you are using. I already have done this, so I'm going to go back here and say kubectl get all. Get all will tell me what exactly the objects that are created at the moment in my cluster. It seems like there is only one service created called the Kubernetes, created by the Kubernetes itself, which is of type cluster IP, the one which I mentioned a minute before. This means the service is available only within the cluster. Please do not touch this service. This is owned by cluster, or this is owned by Minikube. Okay, now I want to run my application inside this, so I will have to run both deployment as well as service YAMLs. So to do this, I'm going to go back here and say kubectl apply -f k8s/manifest. We'll start with the deployment first. Deployment website got created. Wonderful. And let's do the same thing, apply -f k8s, again manifest, and the service.yaml. So both deployment and service YAMLs must have been created. Let's confirm them. kubectl get all. Wonderful. And I can see here the website, my website deployment has created a pod named my website and some unique ID. One container is running, which means it is already running. And there is a service also, my website, which is running on port 31809. That's the best part of it. When we say the services type is something called the node port, which you can see here, it will create a port for your node so that you can access this service directly on that port 3180809. Let me see what's my Minikube IP here is. So maybe I can say Minikube IP. The IP address is 192.168.105.4 and the port number is 31809. So let's come back here and use that IP address, the one here, colon, the IP address is this, the port number is this. When I run that application, I can see that the demo application version 1 is now available, which simply means the application is running inside the Kubernetes cluster, which is what we were expecting. Wonderful. Now things are streamlined, things are looking great. So let me come back here and mark that we are done with the Kubernetes part as well. But as I said, running this deployment and service every time, which will be really painful. So we'll create a Helm chart and start deploying it with the Helm part. Now to do this, I'm going to go back to my application again, somewhere here. I'll create a directory called as a Helm, and right inside this Helm, we'll create a new chart for our application. So I can say Helm create my website chart. Now what essentially it does is like it creates a directory called as a my website chart. If you go to that directory here, you can see inside that directory there are two folders and there are a couple of files. Means there are directories and files. Out of that, the templates directory will contain all the templates. Like if you go back here, there's a deployment template, there's a HPA template, horizontal pod autoscaler, there's an ingress, there's a service, so on and so forth. And if you go for the charts, right now there is nothing, but you can also have different charts there. At the moment, I'm going to delete this charts, and I'm going to come back here and delete everything inside the template. We'll make it very simple. For us, there are two things important. One is the file that we have created, not file, we have created two files. One is this deployment.yaml and another one is the service.yaml. Let's copy both of them into that directory, Helm, my website chart, and templates. So this is important. Number one means the template. Another one which is important is the values. So if I go towards this directory, Helm, and if I look at the chart.yaml, it essentially is telling you the metadata of your application, like what's an application version, what is the name of your chart, why it is used for, the description, and so on and so forth. All these are comments. You can you can remove them without even looking at that. It's not needed for now, so let's make it very clean. Okay, I have the values.yaml. In this case, I also do not need anything. This is the replica count, which is all right. For me, the important thing here is the image tag, which is going to be very important for, because now we'll use a CI/CD pipeline and we'll make sure that the tag is getting updated so that every new application will immediately start. For now, I will make sure, or I'll make this as version v1. We'll see what's the use of it later. So right now we can say this is image tag v1. So what exactly the values.yaml does is, like, it defines different variables. Like in my case, the variable tag is having a value v1. So when I go back to my deployment here, I want to say that the image is not going to be my website, because whenever there is a change, we'll create a different version of our application, and the version value, I want to take this from values.chart, which is like image tag, and this is the v1 is what I want to take. So going back to the deployment.yaml, and here I'm going to use curly bracket. This is the Helm syntax to read the values dynamically. I'm going to get the values dot image dot tag. When I say values, it's going to read that from values. Image dot tag is like the image is the key and the tag is the sub key of it. So precisely image dot tag, we are appending it to the values, which will read the value from that values.yaml. Wonderful. Now how do I use it? How do I deploy it? To deploy it, first of all, I'm going to go back and again get all and make sure that they all are running right now. So I can see the deployment is also running and service is also running. Let's remove them and deploy them by using Helm. So I can say here kubectl delete deployment my website, sorry, it's my website got deleted, and delete the service named my website. So we have created a service also with the name my website and deployment also with my website. So let's verify whether they are gone, and I can see they are gone. Now that we are inside the Helm, we will create a Helm, we will deploy the application by using the Helm chart by saying Helm. I can say install my website, a name of it, and where is it? It's in my website.chart. Okay, so that's a path. And as you can see here, it says the status is deployed. And what is deployed? It has deployed everything inside that templates directory. So if you look at the templates, you are having deployment and the service, and both of them must have got deployed. Let's confirm that by saying kubectl get all. If I see both of them, and which I can see here and I can see here, both of them, sorry, this one and this one, which means it got working. The only problem that I can see here, it's like error image pool, which is naturally because we do not have that image named v1 or which is having the tag v1. If I look at the description of it, say for example kubectl describe pod, if I look at this, it is trying to find out the image python cpp / my website v1, and if I look at the Docker hub account, which is somewhere here, I can see it has got the latest. It doesn't have the v1, and that's the reason why it is not working, which is absolutely fine. I'm not worried about that. What I'm saying here is the Helm is doing its job correctly, fine. This will automatically get fixed when we start using the CI/CD pipeline. So going back here, I can see that everything is up to the expectation. I can come back and say Helm, it is done. Helm configuration is done. But to fix that problem, that v1 has to be replaced with the latest build, so I will put this inside a GitHub action. Now if you want to use that GitHub action, we first have to create a repository and connect it to the GitHub one. So I'm going to say git init. This will create a new repository. Sorry for that, I have created in the wrong directory. I should have said this to the main one, because I can see that the K8s, Docker file, everything is in this directory. So it makes sense to create a new Git repository here. Maybe I'm also going to put that git ignore and say this is say for example, because I'm on Mac, it will keep on creating that dsstore file. Let me put that here and ignore it. Let's see what do we have here. So if I look at this, I'm having git ignore, Docker file, K8s, Helm and index.html, which looks okay. Let's put everything inside that staging area and say git commit. I can say initial commit. That's it. Now let's create a new repository on GitHub and let's push this change to the GitHub repository. To do this, let's go back to GitHub. Wonderful. I'm going to create a new repository here. Let's give it a name, say DevOps demo. DevOps demo. That's it. I'll make it public for demonstration and I'll share that with you later. I don't want to create any readme file. I'll just say create a repository. This is empty repository right now. So coming back here, I'm going to copy this and paste it here so that this repository will use the GitHub repository as a remote one. So if I look at the git remote -v, it shows that it has got connected to that GitHub repository. Wonderful. Let's say git push origin -m. I don't want to say origin main every time, so let's use -u. Okay, and probably it is set to origin main. If I come back here, refresh it, I can see that all the files and directories are there inside my repository. Wonderful. Now what? Now I want to go for creating a GitHub Actions directory, and then we will start creating that the CI implementation of it. To do this, let's create a new directory here by saying not here, outside it on the root level .get/workflows. When you go for GitHub Actions, in GitHub Actions you are going to create that workflows directories, and in this directory you are going to put all the different let's say GitHub Actions inside it. So if I go back to that GitHub action, where is it? Did it not create? Okay, let me do it one more time. GitHub/workflows. That's it. So now inside this workflows, I will create a file named as ci.yaml. Name of this file really does not matter. As long as you are having the right contents, it will execute it whenever there is a push. Now I already have created this one, so it takes a lot of time to write this code. I'm going to paste it here and I will explain what exactly does it mean. So we'll start with the name. Name can be anything. I'm giving the name of this as a CI for continuous integration. Permissions content right. This means once I'm done with creating a new Docker image, I want to update this GitHub's run ID as a identifier inside the value. If I look at the Helm, there is a file called as values.yaml, and replace it somewhere here. So v1 will be replaced with the next build that will be creating with the GitHub Actions. To do this, we need write permissions, and that's the reason why we are saying contents equals to write. Now, which branch will it use when it wants to run that action? So I'm saying this will run on the branch main. So whenever there is a push on the branch main, it will run that job. It will ignore a Helm//star. In a sense, even if you are modifying anything inside the Helm, it will kind of ignore it. I mean, if you are having a file called as readme, for example, I don't have it right now, but if you are having that in future, and if there is a change inside it, I don't want to run any pipeline or any CI action for that. It makes no sense to do it, and that's the reason I want to ignore that path whenever it's kind of pushing some changes. Important part in this YAML file is this jobs, because here we are going to put the definitions. So I have two jobs here. One is the push job and another one is something called as the update Helm chart. Let's start with the push job first. So essentially, every single job requires you to tell the GitHub to which you can call it as the container it is using. So I'm saying it runs on the Ubuntu latest. I'm going to use the Ubuntu as a base. Then I want to check this repository by using actions /checkout @v4. Now what do you mean by this? Now whenever you are configuring GitHub Actions, GitHub already has given you so many actions that you can choose from. So if you just go for GitHub Action Market or Marketplace, you can find there are so many different actions available here that you can choose from, and you can just search for it. And for example, if I want to say checkout, so if you look at the checkout, there are many different options available here. For example, this is the default one, checkout version 4, and they have given like how do we use it. That's an action, checkout v4. So similarly, you can find the documentation for these all different steps inside it. So we are checking out the repository, then we are firing up the docker build command. See, if you remember last time we did it manually. We used our command prompt and we used a command docker image build, which I want that CI to do it automatically, and that's the reason why we are saying the docker build set this the docker build command. Okay, then once the image is ready, I want to push it to the docker hub. Now when you want to push it to docker hub requires you to first log in. To log in, you have to have an account, which we already are having it. I mean, I showed you that on my docker hub. Because I was already logged in on that system, I could show you that there is a image we could upload, So mine is Python CPP, and I want to log in with that account. So we are creating a variable here called as a docker hub username, and I want to put the password here as a docker hub token. No one wants to show what the password they are using. So Docker has given an authentication system called as a docker hub token. I'll show you how it has to be done. We are reading that value, username, and the docker hub token from GitHub secrets. Now where will you find them? If you go back to your directory, if you go back to your repository somewhere here, inside it you can go to the settings, and inside the settings you can search for secrets and variables. Within that, go to the actions and create the repository secrets here. So if I go back here, create a new repository secret, I need to create this docker hub username, which is having a value same as the docker hub account that I'm using, that is Python CPP. So let me add that as a secret. Let's add another secret, docker hub token. Follow the same steps, create repository token. This is the one. And how do I get the token then? To create a token, head towards your GitHub account, docker hub account, go to your account settings. Within your account settings, you can find there is an option to create the tokens called as personal tokens. Okay, let's create one. Maybe I can say DevOps demo token. It will be used only for this demonstration, and I will delete it. So I'm going to go back here, make sure that you are having read and write both. Generate. This will create a token. You can copy it. When you say back to token, you are going to lose the access to it. So make sure that you are copying it somewhere. I already have copied it. Going back to my GitHub settings, creating a new secret with the name docker hub token, and let's paste it here and say add the secret. Now we are having both of them, docker hub token and docker hub username. We are done with this part. So what will it do? It will log in on the docker hub, and then it will push it. Now while pushing it, because I'm running the ARM64, that is Apple, this is the M2 Pro, so I'm running ARM64 as architecture. So I'm creating it for both AMD 64 as well as ARM64, one for mine, and if someone wants to take it, you can directly get it from this particular architecture. That's the reason. Now once that is done, you can see we are using the tag here for this particular image as secret docker hub username, meaning Python CPP / my website, which is nothing but the name of that image that we chose last time, and the github.runner id. This is called the runner id. Run id is something called the runner id, which means whenever GitHub will run this action, it will generate a new id which I want to use here for identifying this version uniquely. Now if you recall something, we had that values.yaml where the tag is equals to v1. So what essentially has to happen, When the GitHub runs this Docker image or creates a Docker image and pushes that to the Docker Hub account, it generates that ID, and that ID will be used as the tag. I want to use that tag and deploy my application into my Kubernetes automatically. To do this, this v1 has to be replaced with the newly generated ID, and that's the reason why if I look at the ci.yaml, we have the last step here, update YAML chart. This is the last job, you can call it as, and again it will run on Ubuntu latest. It requires the push to be finished first. This is the push job. It will finish it first. It will push that to the Docker Hub account. Then it will start executing the update Helm chart. It will come back here. It will check out the repository, and this is the script which will replace a tag with the newly created runner ID. This is the tag that we have assigned to our image. Now it will commit that. You can see here I'm committing with my account, pythonspewer@gmail.com. that's my account here, and it will update the values.yaml. It will commit that values.yaml so that our Argo CD will automatically see that it has updated, and it will pull this change and will deploy it onto the server. Okay, so this is what we are going to do now. So I've added this GitHub action under .github/workflows. So I'll have to go back here and add that change and push it to my GitHub repository. So let's see git status. Okay, git add dot git commit -m. Maybe I can say added. This is like a this is like a GitHub actions, and let's push it to my GitHub repository. Wonderful, it got pushed. Immediately when it gets pushed, if you come back to your repository again, if I look at the code, I can see that it has detected the new commit, and you see that one dot here. That means your actions are running. So you go to the actions, and you can see that this is the name that we have given. If you look at that GitHub actions here, this is the name that we have given here. It is appearing, and what it is doing, it is executing that action on that particular commit. So it will first go for the push. This is my first job. You can see it setting up the job, checking out the repository, checking the Docker Hub, blah blah blah. Then it has built that image. It has pushed that image as well. So everything has went well. It has completed the job. Once that job has completed, it is continuing with the last one, updating that Helm chart, and I can see that it also has committed this chart. What essentially does it do? If you look at this push, you will see that it has created a build somewhere here. It has created the build, the image build, see here, and towards the end of it, you can see everything has went well. There is no problem here. It has created the image ID, and if I look at the build push, it has executed this command. If you look at this entire job cleanup, it has executed this command, and probably if I look at Docker Hub account and say refresh, see, it must have refreshed a new a new version of it. You can see that it is kind of it has kind of pushed a new image of it, which is having this as a runner ID. This is a unique ID. Okay, on top of it, if I look at the update Helm chart job, it has executed that as well, which means it has committed and pushed the changes. So if I go to my code, and if I look at the Helm my website chart, if I look at the templates, if I look at the values.yaml, you can see that it is now changed. So earlier I hard coded it to v1 to start with, but if I come back to my account, if I come back here and if I say git pull, and if I look at the v1, it got replaced with our latest runner ID, which is what we were looking for, right? Wonderful. Coming back here, we are done with that GitHub actions. So let's mark it as green, mark it as done, and let's look at the last part of it called as an Argo CD. Now everything is working fine, but it is somewhere I am involved. In a sense, it is where the human intervention is involved. I want to cut down the human intervention and make it automatically deployable. To do this, we are going to use that Argo CD. Going back here and searching for Argo CD. This is the one, declarative GitOps CD for Kubernetes. Is what essentially does it do? It's like whenever it detects there is a change in your repository, which means a Helm file is updated, values.yaml file is updated, it downloads that image from the GitHub, from the Docker Hub, and then it deploys it back to the cluster by using the Helm. This is what exactly it is going to do. See how does it do that. I'm going to go to the GitHub, getting started, and here we'll install Argo CD inside our Minikube cluster. So this is the one. I'm going to create a namespace named Argo CD, and we'll run this last command, which will install all the different components necessary to run Argo CD here. Okay. If I look at get all -n Argo CD, you can see for Argo CD it is still creating it, but it is creating different pods, it's creating different services and other deployments as well. Let's wait for a second. Okay, still creating. Okay, it will take a minute or two. Once this is done, you will see all of them running. So this is running, the rest of them are kind of running also. It will take a minute. Okay, by the time it is doing it, let's go back here and say Kubernetes, or sorry, kubectl get secret -n or minus namespace Argo CD. So if I look at this, it is having the Argo CD secrets here. Now why am I looking at the secret? It is because when I run this application, if I look at the Argo CD, if I look at the pods, I can see all of them are running, which is wonderful, which means Argo CD is running right now. There is a service which is going to make that Argo CD available for us outside the cluster. I mean, at the moment, if I look at the service, say kubectl get service -n Argo CD, I can see that there is a Argo CD server. This is the service. At the moment it is cluster IP, and that's the reason it will not allow you to access this outside the cluster. So what's an option then? Option here is change this type temporarily to convert it from cluster CD to cluster IP to node port. So kubectl edit, this is the service, named Argo CD server with the name Argo CD. This will edit it, and if you go towards the bottom side of it, you can change that cluster IP to node port. Once you update it, if you say escape:\wq, it says it is edited, and if you execute the same command back, you will see that it is now node port. Because it is node port, it is giving you this port number 32384. So if I use this port number, or you can use this one as well, this is for HTTP and this is for HTTPS. Better we can go for HTTPS. Okay, going back here, this is 192.168. it was 105.5. Was it 5? Let me check that. Minikube IP, sorry, it's a 4, sorry, it's 4 it's a 4 colon, this is the IP address. Because it is self-signed, I'll have to go back here and say proceed, which is unzip, it's all right. And this is where I can see the Argo Series UI. What's the username? Username is admin. And where do I get the password? The password is there in the secrets, and that's what I was showing you earlier. So if I look at the secrets, so this is the one, get all secrets. There is a secret called as Argo CD secret, So you can go here and try to get, I'm sorry, not this one, Argo CD initial admin secret. So this is the one that will give you the password. To get the password, you can say kubectl edit secret, name is this -n Argo CD, and this is the password. Because it is base 64 encoded, you'll have to first decode it. To decode it, you can come back and say echo, this is the one. Base 64 is the command that you want to use, decode. This will give you the password. Please do not use the %sign. This is the password, except the %sign. Copy it and paste it here. So now we are logging in with the admin account. Wow, look at that. This is the user interface where we are going to configure a job so that it will sync directly with our GitHub repository. So I'm going to go and say create a new app. You can put an application name, anything. I'm going to say my website because the same name I've used everywhere. Project name, which is the default one. Okay. The sync policy, I want to do it automatically. Now when you say on manual, you'll have to hit this manually, which is of no use. So I'm going to go for creating it or deploying it automatically. I'm also going to click on the self heal. In a sense, if someone has changed anything in your repository, probably has added something, then it will automatically heal itself. I don't have to worry about that. There are many other options you can check later. Right now I'll keep them default and directly go to the repository URL. Where is your source code? My source code is in my repository somewhere here. So if I look at the code, I can go back to the code, grab the repository URL from here and put it right inside this. It has detected that the revision is head, which is of course yes, that's the case. The branches, it's going to be the main, because head is going to always point to the main for us. The path, it has detected it. Under Helm, you have created a chart called as my website chart. This is what the the Argo CD already has detected. I didn't put it, it's by default detected by it. If you want, you can change it though, but it has detected it already, so I'll keep it default. Now where you want to deploy this application, since my Argo CD is running inside the same cluster where I want to deploy my application, so I'll go back here and use the default one. So Kubernetes.default SVC means it is the same cluster in which your Argo CD is run. Absolutely yes. And what's the namespace of it? If you look at this one here, if I say k, or maybe I can say kubectl get namespaces, you can see this is the default namespace which is by default used for running all the applications. This is the one which Argo CD has created. So this is where the Argo CD is running. I want to run my application inside the default namespace. So let's put it as a default. Okay. Maybe I will be using that Helm probably. And where is my values.yaml file? It's the values.yaml. So if you remember, in our Helm website, my website chart, there's a file called as values.yaml where we have kept the image.tag variable there. Rest, I think we don't have to change. We can simply go and create this. Now it will take a second. See, it is kind of progressing. If I click on that, it will tell you what exactly is the current status here is. You already have got this working earlier, probably. You can see it was there. Now it is kind of creating it. So it was created 23 minutes before. If I come back here and say kubectl get all, oh, look at that, it already has made it working. So probably if I look at the kubectl, let's say describe pod, and if I look at this pod here, so if you look at this, it has already found out the latest ID, that is the the tag we have pushed last time, and it has deployed our application. Wonderful. If I look at kubectl get svc, this is the port number 31908. So if I go back to my 31108, where is it? Here it is. This is the one, and it has deployed the application. Is it running? Okay, it will take a minute, I believe. 31. Okay, so is it running? Minikube IP, it's 504. That's right. Colon 3180908. Sorry, it's not 809. It's 908. Yeah, I can see that it's really working. Wonderful. Now let's do one thing. Let's change some source code as a developer, and let's see if it does that job automatically for me. Okay. Before I do this, this is the current version. You can see 2 minutes before it has synced it. So I'm going to go back here as a developer and change something here. Probably this is version 2.0, and that's it. There is nothing I'm going to change. Or if you want, we can change the color. So we can see it clearly whether it is really working or not. Okay, I'm a developer, so as a developer I'm going to go back and push my changes. So maybe I can say updated the version, that's it, and then we'll push my change. Okay, so when I push my change, just stay relaxed and see what does it do. So when it does the job, because if I look at the GitHub, I can see it has detected, if I look at that refresh, it has detected the updated new version as my next commit. It is already running my action here. If you look at that, it is already running my action. Look at that, here it is, and it is creating that build. It is pushing it, and once it pushes, you will see one more version updated here. Okay, it will take a minute or two to do this. It is pushing it, it is building it right now. Okay, it will take a minute. Yes, now it is updating the Helm chart with the latest tag. Wonderful, it has done that job. That means everything is working fine. I'll just go towards this and wait till this Argo CD detects the change from our GitHub repository. When it detects, it will do these things automatically for us. I don't have to do anything. I can just come back here and see that it is calling that application as a healthy right now. Healthy right now. You can see that here also. Now it will take a minute or two. So it has created 3 minutes ago. Okay. It has synced 3 minutes ago. Okay. It will take a couple of more minutes, and then it will automatically sync with the head version. Head is nothing but the main version of our GitHub repository. So let's wait for a couple of minutes and see whether it does the job. If you remember, the first one was not working because v1 was not working there, you know, so that's the reason. But now it is healthy, right? So it will take a minute or two. Let's wait. You can also sync manually, which I don't want to because I want you to see this. It is detecting it automatically, and once it does it, probably you will see the new version deployed here. Right now, if I look at this, it is still version 1.0, still it is black. Okay, let's see whether it does the job. It is still calling it as a healthy. It has not detected that. But if I look at my code right now, if you look at the values.yaml, it ended with 888. That was my previous one. But if I go and say git pull now, you see that this is updated values.yaml. So this was ending with 888. Now it ends with 492. That means a new version is already available. Okay, I think one more minute and then it will detect the new change, and then it will bring it here. Because right now, if I look at the deployment version, or if I run that application now, it is still version 1.0. Okay, it will take a minute. I did not configure this Argo CD to run it frequently, so maybe around 5 minutes it is going to check whether it is changed or not. So 4 minutes already passed. We'll wait a minute or two more, and then it will automatically detect it. By the time, I can just go back to my Docker hub and see whether it has updated that here. Sorry, I'll have to go back to my account settings, or you can directly go back to the hub.docker.com. If I see refresh, that was my older one. This is the newer one, 492. So this matches with the 492. That means everything has worked well. Still it has not detected, I believe. It will take, oh yeah, look at that, it has detected it, and now it is processing it. Wonderful. See, it takes a couple of more minutes, so be patient. That's what I can say. Oh, it has created a new version. It says everything is looking great, everything is looking healthy. If I come back here on my application, it was the last version we were running, but when I say refresh, this is the latest version that we are running now. So as a developer, I just involved in the development and pushing my changes. Everything has been done by different tools here. So now if I look at the tools list, what did we do here? We created a simple application. Maybe you can create yourself, or you can get it from your development team. You can containerize it by writing a Docker file using a Docker, of course. Then you run this inside a Kubernetes cluster to create the different replicas of it to make it horizontally scaled or highly available. You can use the Helm, which I showed you earlier. So we have used the Helm to deploy our Kubernetes application. Then we used the GitHub Actions, to create that build or push that build automatically. And then we have used the Argo CD to deploy this application automatically. So last two parts, CI/CD, will be kind of considered as the automatic execution of your entire workflow. That's exactly what you mean by the CI/CD pipeline here. So with this, I think we have seen a small application, how we can start from literally scratch and how we can get it deployed automatically. So this is a demo of Devopsifying your application. I hope this must have given you something that you can learn from. Thank you very much for your time. All the best.